The Schedule Performance Index for time shows whether or not time is being used according to plan. More than that, it shows how well or poorly time is being used on the project. The index opens multiple avenues for assessing and communicating schedule performance. To calculate the index, we need base data. Get the plan value. It starts at $12 and then goes to $24, $36, $48, and so on up to $144 in period 12. Get the earned value. It's not as regular, so let's say it starts at 11.5 and then it goes to 23.5 and then 37, 50.5, 59, 66, and 75.5 in period 7. We'll stop there so that we can see what the index does for us partway through a project. Calculate the earned schedule. You can see the introductory video on how to do that calculation. It goes from 0.96 to 1.96 and 3.08, 4.21, 4.92, 5.5, and 6.29. Next, calculate the Schedule Performance Index for time, the SPIT. It's equal to the earned schedule divided by the actual time. So for us that's 0.96 divided by 1 for 0.96, and then we've got 1.96 divided by 2, and that's 0.98, and then 1.03, 1.05, 0.98, 0.92, and then it's 0.899. It's been rounded to just 0.90 here. The index measures schedule efficiency. You can think of it like the fuel efficiency of a car. If you're on a road trip, you need to know how many kilometers you're getting per liters of fuel consumed. Without the measurement, you can end up out of gas in the middle of nowhere. Schedule efficiency tells us how many periods are being earned per periods elapsed. The measurement keeps us from running out of time before the project is done. Let's graph the measurements. On a simple XY grid, we'll use the vertical axis for the index, and we'll use the horizontal axis for periods elapsed. We'll set the scale. We'll start at 0, and we'll go up to the maximum observed value, which is about 1.1, so we'll go a little bit beyond that and set the top boundary to 1.2. So that gives us this. The next step is to plot the observed values of the index. So we start with 0.96 here, and then 0.98 is a little higher, it's about here. Then 1.03 takes us up here, 1.05 is about there, and then 0.98 is back down here, and 0.90 is about here. Connecting the dots gives us a graph that looks like that. How do we interpret the graph? We need a benchmark for comparison. The nominal value of the index gives us the benchmark. It's the schedule efficiency under normal conditions. That equals 1 period of earned schedule per elapsed period. The ratio of the two yields a constant value of 1.0. We mark that with a straight line. Interpreting the graph then, if the index is below nominal, efficiency is less than planned. If the index is above nominal, efficiency is greater than planned. And if the index is exactly on nominal, efficiency is exactly on plan. The graph shows that efficiency starts a bit lower than planned, but then gradually increases to a maximum at the end of period 4, and then it declines gradually after that, indicating that time more recently has not been used as efficiently as planned. If it's not being used as efficiently as planned, is that a cause for concern? It's hard to tell just from the graph. It shows variance from plan, but on projects, variance occurs all the time. Small variances balance out over time and don't require immediate attention. Large variances are different. They demand immediate action to minimize their impact. So, how do you tell the difference between small and large? You use variance thresholds. They come from governance documents, project plans, or contracts. For the index, a common threshold is 10% variance. To calculate the percentage variance, the formula is start minus end divided by start times 100. So that gives us over the first two periods 0.96 minus 0.98 divided by 0.96 times 100, and that comes out to be minus 2.17. Performing the calculations for the remaining periods, we get minus 4.96 minus 2.36, and then it goes positive 6.53, 6.78, and 1.95. Negatives indicate increases from period to period. Positives indicate decreases from period to period. As you can see, every period-to-period variance here is within the 10% threshold, but analysis is not yet done. When there are 3 or more observations, all headed in the same direction, you have a trend. For a trend, you need to analyze not only each period's variance, but the overall variance. Taking the high and low values of the first trend gives us an increase of about minus 9. So it does not break the threshold. However, the second trend gives us a decrease of about 15%, which clearly breaches the threshold. The threshold breach indicates a need to take immediate action. Summarizing the Schedule Performance Index for time, the index gives us a picture of schedule efficiency, but it goes beyond that. It quantifies schedule efficiency, and that supports further analysis and decision-making within a structured framework. The index shows whether or not time is used according to plan, and it also shows how well or poorly time is being used on the project. For more information on this and other topics, here are some references.